Hello everyone, my name is Chelsea Fountain. I am doing my presentation on the Michaelis-Menten equation. Okay, so first, what we already had started here, I already start writing it out. So we do begin with an enzyme with the capital E, and that is our enzyme plus our substrate, and we have E plus S, and for reaction to ES, and also reverse or backwards reaction, which shows that the enzyme and a substrate can reverse back to the E plus S. So then we have the enzyme substrate to break apart and give the enzyme plus the product P. And so our equation would then look like an ES forward with the E plus product. So we only have one single arrow here because we are examining the kinetics pretty early, and we are not able to reverse at this time. So K1, I said, of course, was our forward reaction, which is our ES formation. K negative 1, which is here. So this is K1. The bottom one will be K negative 1, our reverse. And this is the rate of dissolution. And then we have K2, and K2 is our single arrow, which is also a forward reaction, and that is the rate of P formation. So what we're looking at is, it's the creation of the enzyme substrate complex, which is equal to the sum of all reactions decreasing its concentration. So so you see K1, K negative 1, K2 here, and now we have to solve it. And so we have our instantaneous concentration of the ES. And so that is K1 times E times S, well, the concentration of E times the concentration of S, minus K negative 1 ES minus K2 ES. And all of this will then equal to 0. So this will show us that we will begin to mirror our method for initial rate of reaction. So here is our beginning, and this formula equation was already started on our paper for us for this assignment. So with that, we then have to then break it down a little bit further. So you have E sub T to represent the total concentration of the enzyme. So E total equals concentration of E plus ES. And then we have E equals E total minus ES. And the E sub E total must equal the concentration of E, which is the unbounded enzyme, and the concentration of ES, and ES is our bonded enzyme. And now we want to subtract the ES from both sides, so that way we can, so that way we can solve for E. And we substitute the ET minus ES, and so our equation will begin to look like 0 equals K1, because remember all of that had equal to 0, so 0 equals K1 times the quantity of E total minus ES times S minus negative 1K times ES minus K2 times ES. Now we really have to oh, now we factor out ES, excuse me, I saw that earlier, but we just had to subtract it from both sides to solve for E. But now this is the step where we are progressing towards the Michaelis equation, Minton equation, and we have to rule out for ES. So we would do ES times the quantity, and we have ES times negative K, no, times K1 times S plus K, K negative 1 plus K2, which will equal K1 E plus S. And that, oh, that's E total, excuse me. So K1 times E total times S. And then we will progress to divide to leave ES and get it alone to get ES equals K1 times E total times S. And we're going to divide this by K1 times S plus K negative 1 plus K2. And with that, we then want to times that by K divided by K1 and times 1K1 divided by 1K1. And now we will have ES equals E total times S divided by S plus K negative 1 plus K2 divided by K1. So we then progress to the instantaneous rate of change for product P, which is the function of its reaction. So we will have our product P equals K2 times ES. And with the equation for the concentration of ES, we substitute and arrive at the Michaelis-Menten equation, which of course is how enzymes react with the substrate. And so we first begin with our velocity, which is also our reaction rate, and V equals P divided by dt equals K2 times E total times S divided by S and Km. So K2 can also be interchangeable with Kcat. And Kcat is, or K2 is the measure of how many molecules can be measured per second. And pretty much it just means how we get to Vmax, which the Vmax here, it will be the total concentration of the enzymes times the max number of molecules that can be catalyzed per second in order to get that maximum rate. And our maximum rate will then be our Vmax. So we will have Vmax times S divided by Km plus S. So that is how we arrive at the Michaelis-Menten equation, definitely a Vmax. And remember, that's just the maximum of the molecules and also the total concentration of the enzymes together. So moving on to Km, this is the Michaelis constant, and Km equals K1 plus K2, K negative 1 plus K2 divided by K1. And Km is the concentration of the substrate S at which the reaction rate is equal to half of the max velocity, and that also tells us about the infinity of the substrate. So I hope this video made sense. It was pretty difficult, but I did learn a lot from this. And thank you, and I hope you enjoyed this presentation. Again, my name is Chelsea Fountain. Bye-bye.